now, beneath Yellowstone National Park, a monster sleeps. Not the kind you see in movies, something far more terrifying. It's a supervolcano capable of drowning half of North America in ash and plunging the world into years of darkness. But here's what keeps geologists awake at night. Yellowstone isn't even the worst thing that could happen to us. There's something bigger, something that's wiped out 90% of all species on Earth. Not once, but repeatedly throughout history. And the truly chilling part? We might be triggering the next one ourselves, right now. Every few years, headlines scream the same apocalyptic warning. Yellowstone is going to erupt and end civilization as we know it. To understand just how catastrophic that would be, we need to put it in perspective. Remember Mount St. Helens in 1980? The largest volcanic eruption ever recorded in the continental United States, creating the biggest landslide in Earth's history. It seemed world-ending at the time, but Mount Pinatubo in the Philippines, which erupted in 1991, was 10 times more powerful. That eruption actually cooled the entire planet by up to 1 degree Fahrenheit. Then there was Mount Tambora in 1815, 10 times bigger than Pinatubo. Its eruption led to the infamous year without a summer, triggering widespread famine across the globe. Crops failed. People starved. Entire communities collapsed. Now multiply that by 10. That's Yellowstone. According to Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, the caldera has unleashed 3 massive explosive eruptions over its history: 2.1 million years ago, 1.3 million years ago, and the last really big one, 631,000 years ago. That final eruption formed the Yellowstone caldera that occupies the heart of the national park today. When Yellowstone erupts, it doesn't just explode, it collapses under its own weight. The ash plumes are so massive and heavy they implode, creating dense clouds of superheated gas and rock that race across the landscape at hundreds of miles per hour, incinerating everything in their path. That initial shock wave and pyroclastic flow would kill everything near the blast instantly. But the real devastation comes next: the ash. Computer models show the ash plume spreading in concentric circles from Wyoming. The densest zone, over 1,000 millimeters of accumulation, would bury everything from Montana to Colorado. It would be dark at noon. Beyond that, ash would blanket the American heartland, covering the nation's breadbasket. Unlike wildfire ash, volcanic ash is made of rock. It doesn't biodegrade. It never goes away. Breathing becomes nearly impossible. Communications shut down. Fields are buried. The magnitude of cleanup would be staggering, if cleanup were even possible. And volcanic eruptions rarely happen just once. Imagine dealing with this catastrophe, then having it happen again weeks or years later. When do you recover? How do you move on? But even this nightmare scenario isn't the worst part. The global cooling from atmospheric sulfur and ash could drop temperatures by several degrees Fahrenheit. And quickly, food production would collapse. Famines would sweep across continents. The global consequences would be catastrophic. The good news, sort of. Here's where I need to tell you something surprising. You probably shouldn't worry about Yellowstone erupting tomorrow, or next year, or even in your lifetime. Poland is emphatic. I guarantee Yellowstone will not erupt tomorrow. Before any eruption, we'd see dramatic warning signs, huge swarms of earthquakes, ground swelling by many feet, park-wide changes in hot springs and geysers, dramatic shifts in ground heat and gas emissions. As of November 2025, Yellowstone remains at background activity levels with routine seismic activity, including 180 earthquakes in October alone, the largest a magnitude 3.7. The caldera is actually subsiding, as it has been since 2015, and geyser activity remains sporadic, suggesting no major eruption is imminent. Moreover, groundbreaking research published in January 2025 in the journal Nature revealed where Yellowstone will likely erupt next: the northeastern portion of the park, near Sour Creek Dome. Using advanced magnetotelluric imaging, scientists discovered that magma storage is concentrated in 4 separate reservoirs rather than one massive blob, with only the northeastern region still being actively heated by deep mantle rocks. This means any future eruption, hundreds of thousands of years from now, would likely be a massive lava flow rather than a civilization-ending explosion. Poland emphasizes that despite sensational headlines, a Yellowstone supereruption probably wouldn't cause human extinction. These explosive eruptions simply aren't long enough or impactful enough to cause global extinction events. But there's something else, something that absolutely can cause mass extinctions. Standing at Waklella Falls in the Columbia River Gorge, 600 miles from Yellowstone, you can see evidence of something far more terrifying etched into the canyon walls, layer upon layer of ancient lava flows, stacked like a geological history book of apocalypse. To understand what created this, you need to grasp how the Earth really works. Imagine a pot of water on your stove. Heat rises from the bottom, creating circulation. The same thing happens inside our planet, but with rock. These upwelling plumes of superheated material from deep within the Earth, possibly from the boundary between the core and mantle, are primary drivers of plate tectonics. When one of these massive plumes reaches the surface, it starts to melt. It pushes up the Earth's crust, and the melting produces a tremendous amount of magma. Magma that wasn't there before. What happens next dwarfs anything we've discussed so far. Eruptions of up to 10,000 cubic kilometers of material in a single event. And these events don't happen just once. They repeat over the course of what geologists call a large igneous province, or LIP for short. Lava flows blanket the landscape, traveling hundreds of kilometers without cooling. The flow rate is so high that single rivers of molten rock can fill in entire valleys and form stacks of basaltic rock kilometers thick. The most recent such event in North America began about 17 million years ago. The Columbia River flood basalts. If you could have witnessed it, you would have seen a hellscape beyond imagination. Massive outpourings of lava from eastern Washington, eastern Oregon, and western Idaho flowed all the way across the states into the Pacific Ocean. The deepest parts are over 4 kilometers thick. That's not a typo. 4 kilometers of solid lava. And here's the twist. Yellowstone itself is evidence of this massive event. It's a hot spot, essentially an opening in the Earth's crust that hasn't fully closed since that massive eruption. As the North American plate moves over this stationary hotspot, it creates a chain of volcanoes, the youngest sitting right where Yellowstone National Park is today. These large igneous province events happen every 10 to 30 million years. The Columbia River flood basalts is the most recent, but far from the largest. The true titans include the Deccan Traps in India, the Siberian Traps in Russia, and the North Atlantic Igneous Province. These events emplaced millions of cubic kilometers of magma in geologically short periods. Remarkably, the scientific community didn't fully recognize large igneous provinces until the 1990s. and their discovery has revolutionized our understanding of mass extinctions. For decades, geologists ignored mass extinctions because they couldn't explain them. Then, in 1980, the Alvarez team at Berkeley discovered evidence of the asteroid impact that killed the dinosaurs 66 million years ago. Suddenly, mass extinctions became scientifically acceptable to study. Scientists began comparing the dates of known mass extinctions with the formation of large igneous provinces. At first, the dates weren't precise, but they seemed to match up. As dating techniques improved over 3 decades, the correlation became undeniable. Of approximately 14 to 15 mass extinctions in the last 600 million years, almost all match up with large igneous province eruptions. The end Permian extinction 252 million years ago, the most severe in Earth's history, eliminated 90% of marine species and 70% of terrestrial species. The Siberian traps. Large igneous province has been definitively linked to this catastrophe, with new 2025 research revealing that massive methane emissions from oil deposits heated by the eruptions may have initiated the global warming that triggered the extinction. But how do these volcanic events cause global extinction? The answer is climate. When a large igneous province erupts, it releases tremendous amounts of volatile gases, carbon dioxide, sulfur, and increasingly recognized as critically important, methane. The carbon dioxide released warms the Earth significantly. Almost without exception, large igneous province events are followed by these local hothouse climates, intervals of abnormally warm temperatures that last a few million years. But here's the critical detail. The onset is often abrupt. It's this rapid initial pulse that's necessary to cause mass extinctions. Species simply can't adapt fast enough. After that devastating initial pulse, the Earth continues warming, but more slowly. And paradoxically, this gradual, longer-term warming can actually lead to a diversification of life over millions of years. It's the speed that matters. Rapid perturbation? Widespread death? Slower forcing over millions of years? Life adapts and even thrives. Our Earth is incredibly resilient and adaptable, just not quickly. Does this sound familiar? Scientists increasingly agree that we're now entering a 6th mass extinction event. But this one isn't coming from outer space or erupting magma. It's driven by us. To understand our current crisis, paleoclimatologists have studied an event 56 million years ago called the Paleocene-Eocene thermal maximum. It was triggered by rapid emission of greenhouse gases, likely from a large igneous province. Global temperatures spiked by 4 to 6 degrees Celsius. The world experienced dramatic environmental changes. Here's what should terrify you. The rate of CO2 released during that ancient catastrophe was still 4 to 10 times slower than what we're causing today. Let that sink in. We are currently releasing greenhouse gases at rates equal to or exceeding the volcanic activity that caused previous mass extinctions, like the Siberian traps. Because of our burning of fossil fuels, carbon dioxide levels are rising faster than they ever have at any point in Earth's history. The current species extinction rate is estimated between 1,000 and 10,000 times higher than natural extinction rates. Recent studies show that 48% of 70,000 monitored species are experiencing population declines, while only 3% show increases. Vertebrate wildlife populations have plummeted by an average of 70% since 1970. Unlike previous extinction events caused by natural phenomena, asteroid impacts, volcanic activity, and the like, the 6th mass extinction is driven by human activity, unsustainable land use, water consumption, energy production, and climate change. Previous mass extinctions were caused by factors entirely beyond anyone's control. Asteroid impacts, volcanic eruptions from the planet's depths, climate shifts driven by geological processes operating over millions of years. But the current extinction rate is being pushed higher by human activity. And that means human activity can also reverse this trend. We have a choice that no previous generation of life on Earth ever had. We can see the catastrophe coming. We understand the mechanisms. We have the technology and knowledge to change course. The window for meaningful action is closing, but it's still open. Policy changes that increase conservation efforts, transform land use patterns, and dramatically reduce greenhouse gas emissions can slow this extinction event. But we must act with the same urgency we would if Yellowstone were showing signs of eruption. Because in many ways, what we're doing is worse than Yellowstone. A volcanic eruption happens, and then it's over. The damage is done, but it stops. What we're doing doesn't stop. Every day, we continue adding to the problem, warming the climate faster than it's warmed in Earth's entire history, faster than during the catastrophic volcanic events that killed 90% of all species. Large igneous provinces will erupt again. The Earth will continue its cycles of heating and cooling, its continual reshaping through geological processes, but those events are tens of millions of years away, beyond the horizon of human concern. What we're facing now is immediate. We are the large igneous province. We are the climate-altering force. And unlike those ancient volcanic catastrophes, we have the power to stop. The question isn't whether Earth will survive. It will. The planet has endured 5 mass extinctions and recovered each time, though recovery took millions of years. Life is resilient on geological timescales. The question is whether we'll survive, whether our civilization will endure, whether the world we leave to future generations will be one worth inheriting. The monster beneath Yellowstone sleeps soundly, and will for hundreds of thousands of years. But the monster we've awakened, climate change driven by our own actions, is very much awake. And unlike Yellowstone, we can't simply monitor it and prepare. We have to face it head-on and actively work to stop it. The choice is ours. The time is now.